Hey guys, welcome back. We're going to web scrape this page. However, you guys can choose to web scrape any HTML page you guys want. And then here's what we're going to do. As you guys saw, we're going to skip ahead for a second. This is the elbow of the text, the K's. So which is 9. We're going to skip ahead for a second. So basically, we're going to web scrape a web page. We're going to find the number of K's where the elbow is, and then we're going to build a K-means model, and then we're going to predict it. We're also going to visualize it using PCA. As you guys can see, we're going to visualize it later, and then we're going to print the centroids. Okay, guys, let's get started. As you guys know, you guys can use any HTML web page you guys want, just as long as it's text you're dealing with. This is my personal blog I wrote for coffee health benefits, but that's another subject. Okay, we're going to import pandas as PD, and then import NLTK, pip install this, download punct. Okay, and then URL open, beautiful soup, which is the web scraping framework. Here's the HTML equals URL, open read, asked, raw beautiful soup HTML, get the text. And then tokens equals the NLT keyword. So we're going to tokenize it, and then we're going to tokenize the raw, and that equals tokens, the tokenized versions. We're going to print the tokens. There we go. And then we're going to print raw just for humor. Okay, guys, as you guys can see, the TDI of Vectorizer is supposed to find similarities in words. If you guys have seen that, we've also used this in the in the remember my web apps I've used, and also my recommender system web apps, where we use TDI Vectorizer in the content-based recommendation systems because it finds the similarities in words. Okay, anyways, Vectorizer equals TDI of Vectorizer. Okay, X equals the transform tokens, Matplotlib for later, and then KMeans. And guys, before you use a KMeans, it doesn't matter what the data is. You have to find what's the best K to use. Same thing as a KNN, only this is different. KNN is for classification. But the same thing for K and K. K-means clusters equals K. We're basically getting the range. Fit X. Guys, remember X? The sum of the distances, inertia. Plot the square distances. And K is at the bottom for the Ks. As you can see, here's the elbow right here. So we're going to go with 9. Okay? It's finding the similarities in words. So K equals true K, 9. Okay, pass those parameters right here. Model fit X, labels, web scraping text clusters, and that's just for fun. X, clusters and labels, CL. As you can see, looky right here. There's the words, and then print the labels. Okay, fit predicts, print label. And here we're going to get the PCA. NumPy is NP. We're going to import PCA. Principal component analysis. Model indices equals model.fitPredictX. PCA components 2. Scatterplot equals PCA transform X to array. There's the colors. And then the x-axis for O and the scatter plots. Subplots 10 and 7. Change that to whatever you guys want right there. Whatever size you guys want this. Okay. Scatter X and Y axis for the colors in this range for the model indices. Okay, for I in text, enumerate the labels. Annotate, text, x-axis, y-axis, the size 10. Although you can change that right there. And then here we go. As you can see, there's a lot of similarities in the words I wrote, huh? Only one of them's kind of out there, huh? Okay. We're going to arg sort the center clusters. Print the centroids, the ordered centroids, and just for fun, the model cluster centers. Guys, this is unsupervised learning. Later on down the road, when I do another one of these unsupervised learning ones, what I'm going to do is I'm going to do one where we visualize the top words. That's actually kind of what I should have done. And there's a lot you can do with KMeans. The TDI of vectorizers used in text for machine learning for also content-based recommendation systems, like I told you. And guys, remember, my channel, if you guys are watching for the first time, this channel usually is more technical, more on the machine learning engineering side than it is the data scientist side. However, I'm taking a break from the technicalities because check out my other videos. If you guys want a machine learning engineering, so ML ops pipelines with SageMaker pipelines, check them out. I got so many of them. They're all using XGBoost model for regression and classification, binary and multi-class. Check out my videos. If you guys like AI machine learning web apps, check out my videos. I got plenty of them with Streamlit. On some of my videos, I even offer code, links to the GitHub. And check out my channel. I've got one more unsupervised learning where we visualize clusters. I also got a AWS SageMaker KMeans clustering. I've got a lot of SageMaker videos. I've got Google Cloud deployments, Azure deployments. You name it, I got it on my channel, so check it out. I got convolutional neural networks. Hypertuning the parameters of just some machine learning models, some basic stuff. You name it, I got it basic to advanced. And guys, one more thing. Remember, for unsupervised learning, because it's unsupervised, the elbow, which is literally right here, because look, it's the biggest bend in the visualization. So it's obviously 9. You see, because if I passed a different parameter, which would not have been the true K, it would have been a terrible model. So guys, always remember that. If you guys are new to machine learning. Anyways, guys, check out my channel. Be sure to hit like and subscribe if you like it. Share it if you feel this video or another video on my channel helps somebody else. Feel free to share it. Also, guys, stay tuned. And if you guys have been watching from the beginning, I appreciate it. And guys, feel free to leave a comment if there's a video you guys want me to do, if it's not on my channel already. Because I've got reinforcement learning as well. Reinforcement learning for trading. You guys name it, I got it. There's over 100 videos on this channel. Anyways, guys, stay tuned and be sure to hit like and subscribe. Thank you guys very much. I appreciate y'all.